So today we will discuss about the databases, right? So database, is very important for the collections and storing the data. So normally in organized way, collecting the data and storing it in the databases. So that's why uh, electronically they are storing the data. So when they are maintaining the databases, it allows them for the efficient data management and retrieval of data and analysis of data. So the databases, I think you study the databases basically in the IT subject, so that you can have some idea about the database. So storing critical information. So databases store internal data elements, sales information, customer data, financial records, and other critical information. So then we are discussing about the internal data. So the internal data mainly stored in the databases. So then the internal data elements, already we have discussed about a lot of internal data elements, like sales information, customer data, and financial records, and other critical information, like Salesforce performances. And these are the informations available within the organization. Normally, these informations, these data are stored in the data warehouse. This enables the marketers to analyze the patterns and track the customer behavior and make a data-driven decision. So that means with the data, they can analyze the pattern. What is the pattern in the market? What are the trends in the market? So they can analyze and track customer behavior. They can track the customer behavior and make a data-driven decisions. So data-driven decision in the sense when they are taking a decision, they are taking decision based on the data. Simply, they don't take a decision like ad hoc decision. They are taking a decision based on the evidence of data. So that's why normally data-driven decisions are efficient because they are taking a decision with the help of a data. So that means with the evidence they can take a decision. So then that decision may be very efficient. So now we can see the type of databases, right? So a relational database. Relational databases normally SQL, structured query language you studied, I think, from the Access. So these databases store data in tables with the rows and columns. Right? Simply, you can recall the database in the Access, the column and rows. These they use structured query language (SQL) for managing and querying data, right? Managing the data and querying in the sense. So if you want to take some information specifically, so then you can use the query to get the data. Example include MySQL, uh, PostgreSQL, and Microsoft SQL servers. These are some examples of databases available in the relational databases. Another type of databases is NoSQL databases. That means these databases are designed to handle unstructured data. So SQL data are designed to handle the structured data, but the NoSQL databases are designed to handle unstructured data and are often used for big data applications, right? So the big data nowadays, the big data is very popular in the marketing because of the day-to-day operations and from the marketing environment, they are collecting a lot of data. So then they want to not only collecting the data and then they want to do the analysis, storage, handling this, and then that's why the databases is very important to handle this big data applications. So that's they include document databases. Document databases like MongoDB. So the MongoDB is now we can say I will show you the online these databases available. Key value stores, another one Redis, column family stores, Cassandra, and graph databases, Neo, or 4J. These are some examples. Now I will show these databases.
Redis, an in-memory multi-model database famous for its sub-millisecond latency. It was created in 2009 based on the idea that a cache can also be a durable data store. Around this time, apps like Twitter were growing exponentially and needed a way to deliver data to their end users faster than a relational database could handle. Redis, which means remote dictionary server, was adopted by some of the most heavily trafficked sites in the world because it changed the database game by creating a system where data is always modified or read from the main computer memory as opposed to the much slower disk. But at the same time, it stores its data on the disk so it can be reconstructed as needed, which means the database is fully durable, supporting things like snapshots and backups. Every data point in the database is a key followed by one of many different data structures, like a string, list, hash, or stream, so you can store data naturally just like you would with your favorite programming language, as opposed to squeezing it into a bunch of tables or JSON documents. Interacting with the database is handled with a simple set of commands, like set followed by a key and value to create data, then get followed by a key to read data. Historically, Redis has been described as a key value store and is often used as a cache to make relational databases faster at scale. But here's where your mind is about to be blown. Redis is perfectly suitable as a primary database and can dramatically reduce complexity because making things go fast at scale is the primary cause of complexity in the first place. With Redis, your database is already fast. No need for a complex caching layer. But you might be wondering, how do I model complex relationships? Today, Redis is what you would call a multi-model database, supporting a variety of different database paradigms with add-on modules that you can opt into as needed. If your data contains relationships, bring in Redis Graph and query it with Cypher, or use the JSON module to structure your data as a hierarchy, just like a document-oriented database. Then use the search module to turn your database into a full-text search engine. And it even has modules for AI workloads, time series data, and more. The quickest way to get started is the free tier on Redis.
These databases store data in tables with the rows and columns. So when we see some examples in marketing, customer relationship management, they can use the SQL because CRM systems like Salesforce use relational databases. Salesforce means salespeople use relational databases. That means MySQL like that to store detailed customer information. This includes contact details of the customers, interaction history, right? So then when they communicate, right? So the interaction history, purchase history, right? And customer preferences. These are stored in these relational data databases, right? So then here, marketers can query the database to segment customer based on various criteria, location, purchase history, and create a targeted campaigns based on the query they can use, right? So then this they can use the relational SQL, right? So then a retailers want to run a promotional campaign for a customer who have not made a purchase in the last 6 months. So then they want to understand who have not purchased for the last 6 months because they have all the customers' details. From that, they can make a query to identify the customers, right, who have not made a purchase in the last 6 months. So then this database facilitate the retailer to identify that customers. So then using the SQL queries, the marketing team can extract the list of these inactive customers from the database and send the personalized emails to the special offers to re-engage them. So that now you can understand how they can use this relational database. So then we can discuss about this NoSQL database. So now NoSQL databases related to the documents and other things already we have discussed some examples, right? So MongoDB and Redis like that. Social media marketing analysis are more common, right? Even earlier X, now is the X. Earlier the Twitter, they use these databases. So NoSQL database like MongoDB are often used to store and analyze unstructured data from social media platforms. For social media platform, there's no any structured way. There may be a different type of data may be available in the social media. That's why it is not a structured data. So this includes the text, images, videos, as well as metadata like timestamps and user interactions are available. So then how they can use these? Says we can see some example. A company wants to analyze customer sentiment on social media regarding their new product launch, right? Using the NoSQL database, they can store large volume of tweets, Facebook posts, Instagram comments, right? By applying natural language processing, using that means artificial intelligence like that, natural language processing is a kind of algorithm they can use. So then these techniques, marketers can get overall sentiment about positive, negative, neutral about the new product, identify common themes and keywords associated with the product. So then this now you can understand the differences between these relational databases and uh, right NoSQL databases, right? NoSQL databases, and that means structured query language and no structured query language. So this is now, right now you can understand there are two types of databases commonly used in marketing nowadays, and that's it. So then another one, now we can move towards the data warehouse. So what is data? Data warehouse, we all know that is a kind of a storage. Warehouse is a centralized repository. Repository means it's a kind of a storage designed to store and manage data. Store and manage data from multiple sources. The repository is a kind of a place where they write to store the data and manage the data. From different sources is connected with the centralized repository, right? Centralized repository. So both internal, such as sales record, customer data, most of the time they are taking these data from internal and they are connecting with the central repository. And external, like market trends, social media data. So it is structured to support extensive reporting, right? Like a market trend, social media data, it is structured to support extensive data, extensive report. So then complex queries and business intelligence activities. So the data warehouse is supporting to the extensive reporting and to make some complex queries, right? And business intelligence activities. So the data warehouses are optimized for heavy operations, which makes them ideal for generating comprehensive reports and insightful activities. Using the data warehouse, they can make this. So when we discuss this data warehouse, we should understand, right, how data warehouse supports marketing efforts. So one is the integration of diverse data sources, right? Integration means a connecting by bridging together data from various sources, right? By bridging together data from various sources, the company can perform cross-channel marketing analysis and identify trends that would be difficult to see if the data remained silo, right? So that means integration of diverse data sources. Already we have discussed about multiple sources. So that means diverse data sources by bringing together, right? By bringing together the data from various sources, the company can perform cross-channel marketing analysis. So then from the different channels, so then they can do some analysis and identify trends that would be difficult to see if the data remain, if the siloed means separately, if the data is not connected with the multiple sources not connected with the warehouse, and if it is separately available, it is very difficult to identify the pattern. But when they are connecting the multiple sources with the warehouse, then they can have a data in one centralized place. Then this allows the marketers to do some analysis to identify the trends and patterns. Right. Another one, facilitating complex queries and reports. Right, facilitating complex queries and report. So marketers can generate detailed customer profiles, right? Marketers can generate detailed customer profiles and tailor personalized marketing campaigns that increase conversion rates and customer satisfaction. Right. So marketers can generate detailed customer profiles. Already we have discussed about when they are using the databases, they can have this data about the customers. Now then they can generate the detailed profile and tailor personalized marketing campaigns. Tailoring means making, right? Personalized marketing campaigns means for each individual's right preferences considered when they are creating the marketing messages based on this customer profile. So then this data warehouse is facilitating the marketers to get the detailed customer profiles to create the personalized marketing campaigns that increase the conversion rate and customer satisfaction. So when they are sending the marketing campaigns or promotional messages to individual, so then they are converted to custom. That means normal they are sending to the messages or promotional materials to the general audience. When they are seeing these messages, they are interested and then they write to purchase. That means they are converted as a customer. That means conversion rates and customer satisfaction also. When they are receiving messages, they can get all sort of informations. It makes them happy. So that's why it's the customer satisfaction also increasing by using this data warehouse and supporting business intelligence activities. So the business intelligence tools integrated with the data warehouse. Separately, we will discuss later about the business intelligence or marketing intelligence. So here the business intelligence uh, tools integrated with the data warehouse. The company can create a dashboard and visualizations that provide actionable insight. Dashboard means a kind of summary of the visual representation. You can see, so the simple example, in the cricket board, the scores normally appear in the like a dashboard. So then that give a kind of a summary of sort of information. So then here also they can have a created dashboards and visualization that provide actionable insights leading to data-driven decision making and strategic plan. Right? Can create data the dashboards and visualization. So simply they can visualize it, visualizations to provide actionable insights. So then actionable insights means leading to data-driven decision making and strategy. So that is the purpose, right? So why they are using this? To take some actionable insight. Another one, optimizing for real heavy operations. Right? So the data warehouse optimized for read heavy operations. allows for quick retrieval and aggregation of large data sets and enabling the team to produce a comprehensive reports efficiently. So that means that when they are maintaining the data warehouse, it is normally, as we discussed, it's a centralized repository system connecting the multi-channel sources to get the data. So then it is normally optimizing, right, the operations, heavy operations. That's why it allows for quick retrieval. Quickly they can retrieve and aggregation of a large data sets, right? Allow for quick retrieval and aggregation of large data sets. Retrieval and aggregation of large data sets, enabling the team to produce comprehensive reports. So then they can prepare a comprehensive report with the help of these databases. And another one, enhancing marketing campaigns. Right? So that means increase the enhancing the marketing campaigns. By understanding customer behavior at a granular level, right? Granular level, the company can design targeted marketing campaigns, right? That are more likely to resonate with the specific customer segments. So, then understanding the customer behavior at every level, the company can design targeted marketing campaigns, right? Targeted marketing campaigns, right? That are more likely to connect with the specific customer segments, leading to increased revenue. So then these are the benefits of the usage of the data warehouse, right? As a internal data, right? Source. So, then another one, so data mining. Data mining. So data mining is the process of discovering meaningful patterns, correlation, and trends by sifting through large amounts of data using various statistical, machine learning, and computational techniques. So the data mining is the process, right? Data mining, you know, the digging something, right? So here also they are going to dig the data, right? Data mining is a process of discovering meaningful patterns, correlations, and rates, right? By sifting through large amounts of data using various statistical, machine learning, and computational techniques. Now, you know, these machine learning and computational techniques are available because of the help of these artificial intelligence and these algorithms, right? You can see some exacting patterns, right? Exacting patterns. Extracting patterns and knowledge. Extracting patterns and knowledge. Analyzing the customer purchase data, right? So they are going to do some analysis about customer purchase data. So, say for example, a retail company wants to understand customer purchasing behavior, right? A retail company wants to understand uh, customer purchasing behavior, right? So then purchasing behavior, you know, when they are purchasing, how much they are purchasing, what about their purchasing ability, this. So by applying the data mining techniques, right? Data mining techniques, how they are going to dig the data, such as clustering and association rule mining. The company can identify common patterns and association in the transaction data. Based on the past transaction data, they can identify the common patterns of the customers' behavior, right? Using these data mining techniques such as clustering and association pool mining is one of the techniques available. The company discovers that customers who buy baby products often purchase baby food and diapers together. So now you can understand when they are performing the data mining to understand the consumer behavior of the uh, customers, right? Based on their past transaction history, using some clustering and association pool mining techniques, they can discover according to this example, you can understand customers who buy baby products. Baby products means baby soap, baby colors, like that, right? The baby products, when they are purchasing the baby products, often that same customer purchase a baby food and diapers together. So now you can understand this is the behavior. Not only they are purchasing some baby product like a soaps and colognes and other things, they are purchasing food and diapers also. So then this can give some sort of a information to the marketers to design the marketing campaigns. This insight can lead to better product placement and targeted marketing strategies. So companies along the baby products, then they try to provide the baby foods and diapers. So then they can increase the sales to the baby foods and diapers along with the baby products based on these data mining techniques, right? And analyzing emerging product trends also, they can use emerging product trends. So a retail company aims to identify emerging product trends, right? Emerging products trends, what are the products? So using a anomaly detection algorithm on sales and customer data, right? So this algorithm is available. You don't worry about these technical terms. The company employs anomaly detection algorithms. Algorithms are kind of coding or programs to analyze sales data and customer feedback, right? Sales data and customer feedbacks. These algorithms can pinpoint unusual spikes in the popularity of certain products, unusual sudden increase or changes, spikes in the popularity of certain products. They can observe unusually the spikes, increase, or there may be a change. So changes in purchasing patterns or emerging preferences among customers they can do when they are doing the mining techniques. They can understand this. So then outcomes of this, by identifying clusters of increased interest in specific products or categories, the company can quickly adapt its inventory, marketing campaigns and promotional strategies. So this proactive approach allows the company to capitalize on emerging trends, right? This proactive approach means so then they detect before it make a serious effect. So then in advance they can detect. That's a proactive approach allows the company to capitalize on emerging trends, meet customer demands more efficiently, and stay ahead of competitors. And they are stay ahead of competitors. For example, if the algorithm detects a sudden rise in the sales of eco-friendly products in a particular region, the company can swiftly increase stock, right? So then they identified there are some pattern, they identify some products are moving fast, unusual spike, that means increase in the sales unusually. So then they can detect that pattern in advance. That means proactively they can detect it. When they detect this in advance, what they can do, they can take some actions like keeping the stocks right in hand to meet the demand. Right, if the algorithm detects a sudden rise in the sales of eco-friendly products in a particular region, the company can swiftly increase the stock, launch targeted marketing campaigns, and promote related products to maximize sales and asset satisfaction. right? So then these the examples now you can understand they are using the data mining techniques is giving some advantages, right? Right. So then now we can stop here.